Hello there, and welcome to the Infomercial and Chemistry Show. I am your host, Joshua Sones. Today we're going to be discussing the chemistry behind sound-based communication. So, when you think of communication, obviously the first thing that comes to mind is going to be a wide variety of subjects. Anything ranging from the telegraph to me conversing with you through this video feed, or perhaps by taking this lovely device here and communicating with somebody across the seas, or even maybe flipping out the board and typing out a certain message. Of course, today we are not going to be discussing any of those visual topics such as email or any newspaper-based or text messaging. Rather, we are going to be discussing sound-based technology. Of course, the chemistry behind the sound-based technology and the ear and everything included up into the mind is rather a long process indeed, from which the sound is produced to the speakers all the way to the brain is separated into many distinct parts. Wow. In this edition of Infomercials and Chemistry, we are actually going to delve right into the data aspect and more informational portion of this commercial. Beginning with the phone here, obviously produced by Note Corp, it is not exactly the largest phone, nor is it the best, but it is able to produce certain sounds out of the speaker. Taking these sounds that are produced by the speaker, one could actually hold it up to their ear and actually receive a form of communications. Of course, this is a rather simple prospect. To break it down into a more complex form, the speaker itself is producing a certain amount of barometric pressure variations. These variations actually affect the wavelength speed and the type of ones that are perceived by the ear. Once the speaker here produces these sound waves or changes in barometric pressure, it will actually create a rippling effect, also known as sound wavelengths. These wavelengths are then sent towards the outer ear being made of keratin and another form of protein, which is composed majority of cartilage, receives this similar to that of a satellite dish. Once the sounds then go down into the ear canal, they are first met by the eardrum. The eardrum, being composed of calcium, potassium, and many forms of proteins, acts similar to a sheet of skin almost. It's covered with a form of mucus that allows sounds to traverse over the eardrum, creating certain vibrations. These vibrations then travel further down the ear tube, which then gets linked up towards the stapes, the malleus, and the incus. These three bones, being composed of a calcium-based bone structure and actually being composed more of cartilage than bone, acts as a form of separator, which separates the sounds into the three distinct forms. These three distinct forms are then sent further down the ear canal, which then reach the cochlea. The cochlea is a shell-shaped structure that is composed mostly of calcium and protein bases. This, of course, is a very hard substance and allows for easy ricochets of the vibrations throughout the shell as it travels from the larger end to the other ends. These vibrations, when traveling through the cochlea, will actually meet certain types of fluids and the stereocilia. The stereocilia is also known as the hair follicles. These follicles, or cells if you would like to call them, are a basic cell formation that takes these sounds, or vibrations if you would like, and transmits them into an electric force. These electric forces are usually very minute and can only range between 80 microvolts and up to 100 microvolts. The first of these fluids is an endolymph fluid. This fluid only is able to receive microvolts between 80 and 90 microvolts. Being mainly composed of sodium with a tiny amount of potassium, which these elements help transport these electric signals into the auditorial center, actually act in such a chemical way that allow the electricity to bounce across the fluid so that it can reach the stereocilia, in which will then go back into the nerve of the auditorial center. However, say that the microvolts is actually above 90, and between 90 and 100 microvolts is the periolymph fluid. It acts more present to electrical substances, meaning like high-pitched or really sharp sound waves will be more likely interpreted in this form of electrical signal. Potassium is extremely common in this fluid, along with some sodium. So if you could see the adverse effect of how the formal fluid was more common with sodium, while this one is more common in potassium. The stereocilia will then take these sounds and transport them straight into the auditorial nerve. The auditorial nerve itself is a collection of nerve endings bundled together with axons and neurons. These neurons are actually similar to those that are located in the brain. They give off synapses. These synapses, which will contain significant amount of charge, especially that with sodium, positive sodium, which thus allows a message to be sent forward to each dendrite of these neurons. These neurons then send the message in specific tones, usually one particle at a time, up into the brainstem. The brainstem itself is composed of many different elements, usually like that of potassium, sodium, phosphorus, sulfur, chloride, and magnesium. The brainstem itself acts as only a basic decoder and is usually responsible for initial response. After being basically decoded in the brainstem, it is then sent to the thalamus. The thalamus itself is the next step on the decoding process of sounds. These sounds are then sent by the neurons and synapses that occur along the way. At this point, it is usually common to find forms of both serotonin and dopamine, according to your levels of dopamine and serotonin at the time. Serotonin, on the other hand, is a form of euphoric chemical. This chemical acts as a binder between a neuron and the dendrite itself of another neuron. This binder allows a better connection and able for the communication to traverse quicker and be able to be remembered, which is then sent to the auditorial center of memory. Serotonin, unlike dopamine, will actually not necessarily affect the memory centers, but rather will only improve euphoria. Dopamine, on the other hand, is the general all-around euphoria and memory reserve chemical. When dopamine and serotonin are usually very low, take for example back in my math class days, they were usually quite low, so most of the time when the teacher was gabbing away in the back corner, I usually didn't get much. Now these chemicals, which then linked to further memory, is sent to the auditorial center. The auditorial center then takes these communications or sounds and preserves them in memory for future reactions or being able to understand that. This is especially common with developing children who then have a higher sense of dopamine and serotonin, which allows them to understand language quicker and faster. So, now that you understand chemistry behind the sound, you'll be able to finally understand how this phone is so great. It is able to withstand drops. It is able to withstand lightning. It is able to withstand anything. It has brilliant speakers that are able to traverse sound for all your communicational needs. But wait, there's more. Order now and you'll be able to receive a second phone absolutely free. Just pay separate processing and handling. So, here's how to order.